Hello everyone, welcome to Spark Training. So today we are going to discuss about the basic concept of Spark. So first of all, we'll look at what is the advantages of Spark over Hadoop. So the basic advantage over Hadoop for Spark is it is supporting batch processing as well as stream processing. Hadoop doesn't have any capability to process the stream data or real-time data. So inside Spark we have batch processing, and then we have real-time stream processing, and then interactive processing, graph processing, and machine learning capability. So these are the few features which Spark is supporting. So we know that Spark can process data in real time as well as in batch mode, and it can also support different types of workloads like streaming structured data and unstructured data, real-time streaming data, then work on graph processing and machine learning. And then it is 100 times faster than Hadoop. That is one of the key feature of Spark, one of the successful criteria of Spark. This why is most of the industries are using Spark over Hadoop is the ability to process the data in faster way compared to Hadoop. Why it is processing faster? It is because of the in-memory computation which Spark is supporting, and Spark supporting 4 different types of language. That means we can work on Spark with use of 4 different types of language: Scala, Java, Python, and R. And other key features which Spark has, lazy operation or lazy evaluation, which is a kind of optimization techniques in Spark. And Spark support different types of transformations and actions as different methods inside Spark. Spark is also compatible with Hadoop and can process different types of data. And these are the few limitations of Spark when you come with a small file size. A problem with small files. Extremely sorry. These are the few limitations of Hadoop. It doesn't have any support for real-time processing. It is having problem with the small files, and then it is expensive compared to and less number of algorithms and iterative processing. So these are the few feature limitations inside Hadoop. So this is the Spark architecture. So we know that it has different layers. So Spark is sitting on top of Spark core. So that is a basic entity of Spark. So the Spark core can interact with the multiple data sources like Hadoop, NoSQL database like Cassandra or HBase, or can connect to Apache Hive to read the data, and then it can connect to different RDBMS like Postgres, MySQL, Oracle database, or it can read the data from CSV, JSON formatted files, or it can read the data from Elasticsearch. And on top of Spark core, Spark can have different processing models like Spark SQL, which is using a SQL type of languages to connect to the different data sources and process the data. And to work with the real-time data, Spark has a Spark streaming component, and to work with the machine learning, Spark has MLlib library, and GraphX is for graph processing. And Spark has different types of abstracts to work with the different data. One of which is a data frame, and another is data sets. So these are the 2 high-end APIs available within Spark to work with the different types of data. And we know that Spark supported 4 different types of language, though Spark is majority of the Spark code is written in Scala. Scala is the most compatible language, but still it can support. We can work with Spark on Java, Python, and R. So this is a basic cluster architecture for Spark. We have a driver node, and we have multiple worker nodes. and the web program, our Spark program will be existing on the driver program or driver node, and then the Spark context will be created on the driver program. And this is the Spark context which is actually connected to cluster manager, something like Mesos or Yarn, to get the resource available from the worker nodes. So how it is working, Spark context will be connected to cluster manager, and it is a cluster manager which will request for the executor required as per the configuration of the program to the driver program. So once the driver program got enough number of executors from different worker nodes, it can split the work into multiple executors, and then executor start running the task for each worker nodes depending on the amount of data. And once the program executes, the execution of the data is completed, then each executor will be shut down, and then the data will be collected back to the driver program, and the driver can save this particular data on any existing data target framework, like something like a database or HDFS directories or cloud directories, something like S3 or Google cloud storage. These are the few examples of storage sources, storage destinations. So now we can have a basic example how to work with Spark. So we know that the basic abstract for Spark is RDD. So we know that RDD is the basic abstract. So how we are going to create an RDD in Spark, what is an RDD, how it is getting created, and how can we work with the RDDs inside Spark. To demonstrate this, I will use a Databricks environment, Databricks Community Edition. Here we can have availability of Community Edition clusters. So we can create a sample cluster for our training purpose. So we will be using a particular cluster which is already available here. So we can create a notebook here to work with some basic exercise in Spark. So I have created a notebook here. So these are the few existing programs. So first of all, I will just use a simple program how to create an RDD from the sc.parallelize method. So we know that sc is something like a Spark context, which is actually the starting point of any Spark application, where we are creating a Spark context to connect to the resource manager, and the resource manager will be getting the resources which is needed, and then Spark context will submit the job, each transformations to multiple executors, and executor will start running the task. So how we are going to create a simple RDD, we will get to know from this particular example. So let's create a simple RDD from this example. So we have a list which is a list containing 3 elements, we know that. So using sc.parallelize method, we are creating an RDD. So here we will create an RDD called simple data. So here we have created an RDD in Spark cluster. So just to display the data, we will use a method called collect to collect the data from multiple worker nodes. So this is the RDD. So even though it looks like an similar to a list, but it is this actually an RDD which is distributed across multiple nodes. So what exactly an RDD means here? RDD is actually a resilient distributed data set. So what does resilient means? Resilient means it can be reconstructed by its own in case of any data failure or data node failure or network issues. So in case of any kind of issues, it will not be destroyed, it can be reconstructed in case of any failure, data loss happens. So there won't be any physical data loss on any RDDs we are creating. So we cannot change an RDD once it is created. We can create another RDD from an existing RDD. So there are different ways to create an RDD. This is one of the ways we can create an RDD, that is using from the existing data, primary data types like something like array, list, or tuple in Python. So apart from this, if you want to read the data, there are different other ways also to create an RDD. For example, if you are going to read a file from HDFS location or local file system, you can use an xc.text file, something like how we are using parallelize. Instead of parallelize method, we will use a text file method to read the text file into an RDD. And similarly, from an existing RDD, we can create another RDD that we'll understand in the coming detail section trainings as part of this program. So these are the few methods now we can see to work with an RDD. So for example, count is a method we can apply on the RDD to get the number of records in that particular RDD. So when you call this particular method, it will fetch the number of records available in that particular RDD, and it will display on the console. So we have 3 elements in this particular RDD. So these are few operations available in RDD. First will give the first element in this particular RDD, and if you want to print the first 2 elements of this particular RDD, take of 2 will give you the output, the first 2 elements from that out of RDD. So these are the few ways to work with an RDD in Spark. I hope you really like this session. I will come with a different tutorial to explain how we are going to create an RDD from different data sources, and how to convert how to create an RDD from an existing RDD, and how to convert it to a data frame. So by that time, have a good night. Thank you. Bye.